In this video, we're going to talk about combinations, which are another tool in our toolbox for finding either the size of a sample space or the number of ways to do a specific thing. So combinations are the number of arrangements. Well, actually, I'm not sure that's right. The number of groupings is probably a better word. Of our items selected from n distinct or different items. A common example, I'm packing books for a road trip because I know I'm going to be staying in hotels. I'm going to be bored out of my gourd. I have 100 books on my bookshelf. Realistically, I only want to carry about 3 in my luggage. How many groups of 3 books can I choose from the 100 sitting on my shelf? And that's the type of question that combinations can order. An important thing about combinations is the order of the selection of the books off my shelf doesn't matter. Doesn't matter whether I chose, a book on life science first or last. If I chose it off the shelf, it ends up in this luggage, it's going to get read. So combinations don't care about the order of selection. The end result is that all of the items selected end up in the same place, end up being treated the same way, or end up doing the same thing. So for this instance, order of selection does not matter. First, we're going to look at the formula. This is how we calculated it before we had fancy calculators. The notation we use is NCR, where the N and the R are small subscripts. And that is equal to N factorial divided by R factorial times N minus R factorial. So let's look at those moving pieces really quick. So remember that N is the total number of items. So this is the set we're choosing from. And then R are the number of things we're choosing. And for some of you, you may have not seen an exclamation point used in a math class before. That exclamation point is called the factorial function. And what a factorial function does is it takes a number, for example, 5, and it multiplies it by all of the numbers less than 5, all the way down to 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. 2 would be 2 times 1. 3 would be 3 times 2 times 1. 1 factorial is just 1. And 0 factorial is also 1. And these two things are definitions that kind of determine how a factorial works. It is 2026. Everybody has access to graphing calculators on their cell phones, free online, lots of ways to do these. Nobody does this by hand anymore. So on your calculator, you're going to press the math button. You're going to go over to the PROB menu. If you have a modern TI-84, if you have an older TI model, it might be PRB. And you're going to select NCR, which on my calculator is option 3. Some models, when you type this in, you should see a cursor and then C and then a cursor. And you'll type N and then you'll move the arrow over to the second cursor and type R. Sometimes you'll see this on your home screen. If you see the second case, you need to enter the number for n before you go to the math menu is you need a number sitting here and then NCR and then a number sitting here. Whereas the newer calculator models, it's a cursor. You're just going to type n here and then type r here. We're going to go ahead and do an example both ways so you can see both in practice. So Gavin has 12 game discs for his Switch. His game tote only has slots for 5 games. How many different arrangements of games can Gavin pack in his tote? So first thing, I know I have 12 objects, so n is 12. I am selecting from those 12, 5 to put in my tote. And I know that it doesn't matter the order I select them, because as long as the 5 end up in my tote, I don't care if I chose it first or last. So I know that this is a 12C5. This is a combination. And we'll go ahead and do the calculator first, and then we'll double check with the formula. So on the calculator, I want to do 12C5. Maybe if I can get my calculator to work. And I can't. Okay. So we're going to go math. We're going to go over to PR. On my calculator, it's PRB. We're going to choose option 3. And then we have 12 games, and we want to choose 5 of them. And we get 792. 792. So there's 792 different groupings of 12 games that he can make, or 5 games from his 12 that he can make for his tote. To double check, we're going to go ahead and do the formula. So 12C5, I know that that's going to be n factorial over r factorial times n minus r factorial. So this is 12 factorial, so that's 12 times 11 times 10, all the way down. 9, 8, 7, 6, 5, 4, 3, 2, 1. And then on bottom, 5 factorial, I know is just 5, 4, 3, 2, 1. And then times, and then 12 minus 5 is 7. So that's going to be 7, 6, 5, 4, 3, 2, 1. And I see a whole bunch of stuff that cancels. 7, 6, 5, 4, 3, 2, 1. And so now I've just got 12, 11, 10, 9, 8 over 5, 4, 3, 2, 1. And I'm going to go ahead and grab a calculator and do that really quick. If you are doing this manually, it's really important. Parentheses around the top, parentheses around the bottom. Calculators are not always smart. So 12 times 11 times 10 times 9 times 8. And then we're going to divide that by 5 times 4 times 3 times 2 times 1. And I get 792, which is a good sign because that's what we got using the function on our calculator. On your homework, this is totally fine. Make sure that you include the appropriate notation label before you write your answer. If you have any questions on what you just saw, feel free to send me an email. Otherwise, I will see you in our next video.